Hello, my name is Tony Botting, and I'm a simulation specialist at GoEngineer. In this video, we'll show how you might investigate shearing stresses in a bolt. Here's a steel pin and block assembly. We've put an axial tension load on the pin and wish to investigate the stress distribution along the length of the fastener. This could be considered a fully engaged thread, or an adhesive bond line could serve the same purpose. In this quarter section of the model, we're showing exaggerated deformation and the von Mises stress under load. It's difficult to make out the stress distribution at the interface between the bolt and the block. Now I'll show the shearing stress. If you probe the shearing stress, the software allows picking of nodes and graphing the results. As you can see, this technique does not appear very clean from a visual perspective. Additionally, in the graph, you can see the shear stress is plotted against node number, which may not be intuitive. So let's clear the selections and choose the On Selected Entities option. I'll pick an edge here and click the Update button. Now when I graph the results, you can see a nice smooth stress distribution. As a bonus, it's plotted against parametric distance along the edge. The major vertical divisions have 20% spacing on the graph. So immediately you can see from the graph that most of the shear stress occurs in the first 20% of the bolt length up near the head of the bolt. I used split surfaces on both the block and the bolt, which are matched in length. Here are exploded views showing the split surfaces on each component. Notice that I excluded a very short length near the head of the bolt and away from the end of the bolt. This is because you will see very high stresses directly at the edges caused by the rapid change in geometry, which would be unrealistic in an actual structure. In this video, we showed how you might investigate shearing stresses in a bolt.